Welcome back, folks. So now we're going to look at what we call sigma notation, and sometimes it's referred to as summation notation. It's called summation because we're dealing with a sum. Okay, things are going to get added together. So here is our symbol here that we see for sigma or summation. And we're looking to write what you see there as a sum of terms, and then we want to find the sum. Well, please make note that this value down at the bottom is our start, and the value you see here at the top is your end, okay? And whatever comes after it is the formula that you're going to plug into. So our formula is x squared minus 3. We're first going to plug in 1, and then 2, and then 3, and then 4, and 4 is where we are going to end because that's the top number that you see. So we're only going to be plugging in integer values. Okay, so as we do that, all right, we would have 1 squared minus 3 plus 2 squared minus 3 plus 3 squared minus 3, and then finally plus 4 squared minus 3. So when we clean this up, we have negative 2 plus 1 plus, that would be 6, and then this would be 13. So from there we would have a total sum of 18. Okay, so right here we have our 4 terms listed out and added together. Okay, we have a special vocab word here to introduce. So when we talk about a sum of terms, all right, in this case there's 4 terms that we're adding together, we are referring to the word series. Okay, so a series is when you're adding together a bunch of terms. So this unit is called sequences and series. So we are going to be focused on arithmetic and geometric series. Now this particular series is neither arithmetic nor geometric, right? We're not going up by a fixed amount. There's no common multiplier to go from term to term. It's just a generic sequence, all right, or series that we're looking at. And plus you could look at our formula up here, you can see that it's a quadratic. So definitely not arithmetic, definitely not geometric. Okay? Okay, last example, and then I promise to shut up for a while. Well, at least until the next video. So we're looking to write this series. We're kind of working backwards here. All right, we're looking to write this series blah, 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 blah using sigma notation. We're not interested in finding the sum, okay? We're interested in working backwards here, okay? So we need our symbol here. Now, we're going to eventually need a formula, and we know that in the bottom here, if we're talking about a series of terms added together, we're always going to start with n equals 1. And let's pay attention to how many terms we have. Okay, we have 1, 2, 3, 4, 5, 6. So that means I'm going to put a 6 up top there. Okay, so think about this in terms of some sort of a sequence. All right, so again, our focus is on either arithmetic or geometric. So as you look at this here, it's certainly not arithmetic. It's not going up by a fixed amount. So we're talking about going from 3 to 15, from 15 to 75. Okay. Hopefully, you're looking at this and you're thinking, oh, you know what? This is being multiplied by 5. Okay. So this is really geometric. All right. So again, if you were to list out your terms as far as a sequence goes, okay. So not a series. Remember, a sequence is when your terms are separated by commas. The common ratio would be 5. So you're multiplying by 5 to get the next term. Okay? And notice how the first term is 3. So we know a general formula. Okay, u sub n is equal to u sub 1 times r to the n minus 1. Okay, that's given to us. So we're not going to write the u sub n equals piece. All right, whatever we put here is always just an expression. Okay, so there's no equal sign in it. So the first term is 3. Okay, and then times 5, which is our common ratio, to the n minus 1. Okay, notice how if you were to just to test it, if you were to put 1 in here for n, you'd end up with 5 to the 0. 5 to the 0 is 1. 1 times 3 would give you a starting term of 3, right? If you plugged in 2 for n, you'd have 3 times 5 to the first. There's your 15, and so on. That's all for now. Bye-bye.